section D, so we're looking at cats. So we've got two types of cats. Well, two genders. We have the male ones, which have a mean in both kilograms and pounds and a standard deviation. And we also have female cats, which have a mean in pounds and a standard deviation in pounds and kilograms. They're quite different, so it's kind of important to know which one you're talking about. So we are looking at proportion of males less than 14 pounds. So we write that as the probability that capital X is less than or equal to 14. So from a sketch point of view, you've got your mean at 16, we're looking at 14, and we are looking at less than. So we are expecting something that is less than 0.5 by the end. So first off, we're going to have to calculate our Z value. So we've got the probability that Z is less than or equal to, and this is where our calculation comes in. We've got our value of X, our value of the mean, divide by our standard deviation in pounds is 2.2. So that's the probability that Z is less than or equal to minus 0.9091. Now, because that's a negative one, that's going to be the same as the probability of 1 minus the probability of more than no, that's a Z, is more than minus 0.90191. But we can only deal with positive values, so that's going to be the same as the probability. So we can flip the sign and change the sign. This number can then be looked up on the tables. If you're doing it on a calculator, you do it a little bit differently. So if you're doing this on a calculator, you want to be in distribution, normal, and information that we know. From our original picture, we know the upper bound, we do not know the lower, so put in 14, and given that we're looking at the weights of cats, our lower bound can be 0 because you're not going to have any. Our standard deviation is 2.2, our mean is 16, so it gives you your Z value, which is the same as the one we calculated. The lower one you ignore, and it also gives you the probability. So the probability here is 0.1817. Okay, so next we are looking at female short hairs, and we are weighing more than 6 kilograms. So we want, for part 2, we want the probability that a cat is more than 6 kilograms, and that's a female cat. So we sketch our little diagram. We know that the mean of a female in kilograms is 4.77. We want to know about 6, and we want to know about more than. So again, we are expecting something small. So things that we need to write. We need to convert it to Z. So we've got the probability that Z is greater than or equal to value of X minus the mean over your standard deviation, and the standard deviation is 0.36. Okay, calculator. So in this case, our lower bound, because we want it going above, is 6. Our upper bound, something ridiculously big, 0.36 for our standard deviation, 4.77 for our mean. So what it tells us is, it gives us our value of P for our lower bound, so we can write that bit in. So we've got probability that Z is greater than or equal to 3.41, and that is going to give us a probability of 0.0003. That sounds wrong. So checking what we've written. We've got a mean of 4.77, we've got a standard deviation of 3.6, and we've got a lower bound of 6. That's fine. It's just tiny. Okay, so question 3, we are looking at male, and we are looking at the 10th percentile. So 10th percentile is the same as 10%. So things that we end up knowing. We know so we need to know the probability that X is less than or equal to little x is equal to 0.1, because that's 10%. So from a calculator point of view, we want a normal distribution, we want it an inverse normal. From a sketch, what we're looking at is 10%, so that's just a little bit down here. We've still got a mean, and we're looking at males, so if we've got a mean of 16 and a standard deviation of 2.2. So the tail is going to the left. The area under it is 0.1. The standard deviation is 2.2. And the mean is 16. So we're expecting a value of x that is 13.18. Okay, so question 4. We are looking at the 80th percentile and we are looking at female cats. So female cats, 80th percentile. Things that we need to know. We need to know the mean of our female cats, which is 10.5. We need to know their standard deviation, which is 0.8, and we know that the probability is 0.8. So probability that x is less than little x, which is the one we don't know yet, is 0.8. So again, we have a tail going to the left. We've got 0.8. We've got our standard deviation of 0.8. And we have a mean of 10.5. So we have a little x value of 11.17. The other bit of information that with these sort of questions you ought to write down is your z value. Your z value you read off your table and you include with the standard equation and fill in the gaps. Okay, question 5. We are looking at the proportion of female cats. So the proportion of female cats that weigh between 3 kilograms and 5 kilograms. That's the same as the proportion or the probability that a cat is less than 5, and then take away the probability that a cat is less than 3. So that basically gives you the gap between. From a picture point of view, what you're doing is on your first one you've got that bit, on your second one you've got that bit. So if you take that bit away, what you're left with is that bit going up to 5, and then take off that bit going up to 3. So you're left with the middle bit, which is the bit that you need. So if we come out of there, distribution, normal, we are looking at female cats in kilograms. We have a lower bound at 3, we have an upper bound at 5. our standard deviation is 0.36 and our mean is 4.77. So from that piece of information, we are now looking at the probability that Z is less than or equal to your upper bound, which is now 0.639, take away using Z's, your lower bound, which is minus 4.917, and that's giving us a probability of 0.7386. Ideally, you need to use that, write down somewhere that equation with the thing substituted into it as well. Next, we're looking at the proportion of male cats that weigh between 3 and 5 kilograms. So for part 6, we are looking at a different mean and standard deviation. So for part 6, we're still looking at a cat between 3 and 5. However, this time we've got a mean of 7.27 and a standard deviation of 1. So we're going to need to look at the probability that x is less than or equal to 5, probability x is less than or equal to 3. So we've got our new standard deviation and our new mean. So we're looking at the probability that Z is less than or equal to our upper bound, the probability that Z is less than or equal to our lower bound, and that gives us a probability of 0.01, no, 0.0116. Okay, lastly, we are looking at another breed of cat. And this is basically working things backwards. So, okay. So we know it's normally distributed. We know that the probability of 10%, so approximate diagram, we know that the mean is in the middle. Because it's a normal distribution, it's symmetric. So 10% gives us 3.2, 90% is at 6.7. So logically, the mean is going to be halfway between these two, because that is the same size as that. This means that we can calculate the mean nice and easily. So our mean is going to be 2.3 plus 6.7 . and then we divide that by 2 because it's halfway. So we have a mean that comes in at 4.5. Calculating the standard deviation. So we know that the probability that x is less than little x is 0.9, and that occurs when little x is at 6.7. So the probability that x is less than 6.7 is at 0.9. So from here, we need to look up 0.9 on the table, and that tells us that our little z value is equal to 1.28. So we can use the standard equation, which is that z is equal to x minus mu over standard deviation. We can put in the things that we know. So we know what z is, we know what x is, we know what the mean is. The only thing we don't know is the standard deviation, which is what we've got to calculate. So rearranging, we can times both sides by that and then divide both by that. So we should have 6.7 take away 4.5 divided by 1.28, which is 1.72.